Everyone, welcome back to the workshop. Today we are taking a look at the Omtech Polar Lite. This is a 55 watt CO2 laser in kind of the benchtop style we've been seeing a lot lately, but we've also been seeing a lot of smart lasers that are adding a lot of features, custom software, and while those features may be nice, it also drives up the cost. Well, Omtech has come out with the Lite version. They've kind of captured what I would maybe say the must-have creature comforts, but they've left everything else pretty simple. They've left it at a kind of a more value line, tried to keep that price down. So we're gonna go over some of the features and the build of this, what you can expect kind of just physically and mechanically out of it. And then I am gonna show you some of my test results on various materials and items that this laser will work with to hopefully help inform you on if this laser might work for you. So if you're interested in this one or want to just find out a little bit more about CO2 lasers in general, stay tuned. I'm going to jump right into it. All right, first and foremost, I want to thank Omtech for sending this unit out for us to take a look at. They did provide that, but they aren't sponsoring this video. I don't accept payment for reviews. I just ask that I can have a look at the product and give it a kind of a rundown, give it a shakedown for you all. So thanks for Omtech for doing this. And I will have a link down below. I'm gonna go over some of the features, but if you want to dive into the details of the specifications, I'll have a link down below. It is affiliate link, so they'll know that I sent you over there, and I always appreciate you using that, but as always, no pressure. My job is to hopefully break it down, give you kind of the core, my thoughts on it and my experience with it. So let's jump into what you might expect out of the Omtech Polar Lite. As far as the shipping experience and the unboxing experience, not gonna go too far in depth on that. It was shipped in a normal cardboard box that was reinforced on the corners and well packaged in foam. These things always come with more foam than I care, but I know that's a safe way to ship them. When you unbox it, you will need to pull out the honeycomb that is included with this laser, get that unwrapped, and then take off that top layer. And then I suggest you get some help to lift this out of there. I have this set up on a 4 foot by 3 foot table with plenty of room. It is about 32 inches high, so grabbed one of my sons and helped me lift it up onto the bench so that I didn't hurt myself or the laser. It is about 90 pounds, so while you may be able to lift that, it's always good to have a second set of hands and eyes, just making sure you can move it safely. But I didn't see any damage in it. The packaging seemed to work well. And once we got everything unboxed, you can start looking at the rest of the laser. As far as dimensions, it's about 41 inches wide, and that's just end to end, not counting anything that sticks out a little bit. But the frame itself, about 41 inches wide. It is 22¼ inches deep. Again, that's not counting like the handle up front, but that's kind of your base frame to frame. And then it sits about 10½ inches tall. It does have some rubber feet that normally keep it up a little bit higher. I actually have it elevated just a little bit more than that. We'll talk about that a little bit later. All right, on the left side here, we do have pretty much mostly a blank panel. There are these little plugs that do, you can pop them off if you need to, and that reveals the screws holding the panel on. Behind this, there is a water reservoir. So you do on the top have an Allen head screw that goes in here, and there's actually a pairing one down below here as well. This is gonna be your fill and your drain for your water reservoir. This does come filled from the factory, so hopefully you won't have to touch that, but you can see it from the inside of the laser. We'll take a look at that a little bit to check water levels and such, and if the case where you had some contamination or something, or you needed to drain it for another reason, you can do that, but then you'll have to use these to fill back up. The main thing we have over here is the exhaust. Now, this isn't an ideal setup. Please don't do this for yourself. This should be straight, but what we have on this end is there's a metal adapter that goes on here. This is 3 inches, but the inner circle here is just over 1.5 inches. And so that's kind of your true exhaust size. And I'll throw up a photo here so you can see that. But so it does adapt it up from 1.5 inches up to 3 inches. And then I have a 3D printed adapter to go into my 4-inch exhaust system. This is kind of my testing setup where I move lasers around. So ideally you would have a nice easy bend as short as possible. You don't even really want 90 degrees. This is over 90 degrees. You want it as straight as possible. But for testing, this has worked. And then I just added a little electrical tape as a bit of a gasket to make a better fit for my adapter here. But if you're using this type of setup, you're using like a dryer vent out to your outdoors, you will need to kind of make up an adapter type like this, because right out of the laser, it's a 3-inch port. I might show you a quick picture of the back as well. There's nothing there. So you could have this fairly tight up against the wall if needed. There's nothing really to block it that way. Ideally, I might like to see the exhaust come out the back rather than the side. It just gives you a little more flexibility. Yes, it does need to be further away from the wall, but it is what it is, and this would work. If this was a permanent setup, I would rework my exhaust so that this was a nice, gentle bend into the normal piping. But let's swing around to the right side and look at that. All right, over here on the right side, we have a little more going on. Again, this is a plastic panel, and there are little plugs here that are blocking the screws that if you ever needed to take this panel off, you could. All the core electronics are accessed through this panel. So if you need to get at the actual controller or the wiring, that is going to be inside this panel again. So you're going to have to take all these plugs out, remove those, and then you can pop this panel off. Right up at the front here, there is a little bit of a vent, and they do have like a foam filter behind there. So that's going to allow some air to come in and allow some air flow over the electronics in there. I imagine over time, if you have it in a dusty environment, you might need to clean out this filter, but for the most part, that's going to be something that you hopefully never have to open. So starting up front, we do have our main power. They do provide you a couple of keys on this little acrylic keychain that comes with your serial number and such. And so this is how you would turn the laser on. You can flip it on and that will power everything up. Next, we have an Ethernet port. You can put this on the network. I just have it connected via USB, so we do have 2 ports, one to the computer to control the laser, the other one to feed your USB camera in. I know RD works if you use that. You can probably address the laser via the IP, but I haven't tried to set that up in LightBurn. Mainly, I just use the USB, and it works well for me. They do provide a fairly heavy-duty power cord. Here in the US, it's a 120-volt cord. If you're outside the US, hopefully they'll have an equivalent one for you, but it is a fairly heavy-duty cord. And then we have a main power switch right behind that. So if that's off, it doesn't matter if you turn your switch on here that says main power. You need to have that switch on, and then you can switch that on. Then finally back here, we have a grounding plug. So in the US, we do have the 3 wires where this is grounded. If you need to have a separate earth ground where you're at, or you want just some extra security that it is properly grounded, you have access to a ground bus, you can run a wire from here. And then there's just some basic labels here, fire hazard as far as do not leave unattended and such. But then over here, we do have model number, serial number, and then your laser power, your working area, all the kind of your basic stats right there. So a little bit of a nice documentation on the side of the laser. Up top, we do have just a few things. Up front, we have a start pause button. Then we do have an LCD screen, and then just a sticker. This is a QR code to the latest user manual, which is kind of nice that you can get it digitally. So just use a smart device, scan that code. It'll bring up the latest user manual for you. So if I turn the laser on, this will start to light up. The fans on the laser do turn on. It does add a little bit of noise, but you'll see the Omtech logo, and then what you will see on this LCD screen are 2 circles with some information inside of them. The one on the left is going to be your water temperature, and it will kind of track in real time what the temperature of the water is flowing through the system, and it will alert you if it gets too hot. Over on the right side, we have an amp meter, so it's reading in milliamps, and as you run your power through and your settings in your software, it will show you real time the milliamps running through this laser. It does appear that they have the power supply tuned to the controller in this laser so that 100% power in LightBurn registers right around 19 milliamps, which is about the peak power you would want to run through a 55 watt CO2 tube. The other thing on here is just on the bottom, there's a little status thing. It's lit up blue where it's basically saying done and ready. If I was to open up the lid, it will go into an error mode. And that just means that the limit switches on the lid were triggered, and it's going to say there's an error I need to clear. Same thing with the button, it lights up the same color. When I close it, it goes back to blue, which is kind of the standby mode. And when it's running, you should see this as green. I'm going to do my best to show you some of the internals of the laser, and some of them I will try to get a camera inside to show a little bit better. But I want to point out the lid. This is a pretty nice lid. They do have some laser safe glass and acrylic on here, and they are on gas assist. So it will open up, and it is generally safe to spot check what your laser's doing. I wouldn't necessarily stare at it, but this will provide you some protection. They also do have kind of this lip around the sides, so the glass and metal do sit on there, so there's not any direct gaps. There's obviously some air that can get through here, but you don't have a direct line of sight. It has kind of that 90-degree bend, so it's nice to have that extra little detail to provide just a little extra security. As you can see, this lid, it does open up. It doesn't go straight vertical, and so it comes up to maybe, I'm going to say 65, 70 degrees, and then it does have this lip in front. So just be mindful of that. If you're taller like me, you might find yourself this getting a little bit in the way, but there's still plenty of room to access everything in here and get at what you need. So pretty decent construction, some pretty decently sized hinges on the back here. So that should bring it in. Now up here, we do have an integrated USB camera. The wiring's run back there, and then off to that side, we saw earlier where it plugs into the outside. So that is pretty good to go, but this is a pretty short throw between the surface of the bed and up here. So the camera is decent for getting close. In the center, it's gonna be pretty spot on, but as you get out to the extents with that close range and that fisheye effect to get the full coverage, you're gonna have some issues with direct alignment. It'll be great for maybe using up material, but if you're trying to spot something and align it perfectly, that's probably where you're going to want to set up some jigs and such to work with that. Over on the left side, you can see this blue tank back here. This is your water reservoir, and there is a minimum maximum level in there. So that's something to just kind of spot check, and it goes into a radiator here. So I don't believe this is active cooling. It's just going to be able to try to cool it down to ambient temperature through this radiator, and then that's going to move it through the tube. This is your water sensor, so that's reading the temperature of the tube and that's feeding it back to that panel there. And over here is a flow sensor, so that's gonna be making sure that water is moving, otherwise it's gonna kick an error out to you. So if you're ever troubleshooting the water system, most of that is all over here. You do have a stepper motor and belt for part of the drivetrain. And then in the back here, there is your first and second mirrors. And they are going to be a little tight to get at. If you do need to realign your mirrors, it's going to be a little tricky to get at them, but they are, the second mirror is more accessible than the first one. The first one hopefully doesn't need to have a lot of movement on you, but you will need to kind of get in here and get under that. They also do, of course, have some cable chain, keeping everything nice and clean. Not a whole lot to see over on the right side. There are some metal panels here and here. These are kind of protecting your electronics. If we move the gantry forward a little bit, back here is your power supply. Then looking at the back, here we have the exhaust system. There are 6 fans in the back here, kind of going across the bed, and they draw air in, and then it goes into kind of this inner tube that does draw the air out to that port we showed earlier. And then in the back corner, we also have, it's protected by a little rubber cap, but you have a 4-pin aviation plug and then a switch. This is for your rotary access. So the switch down is standard mode for the gantry to move. Switch up will move it over to your rotary access. And for our main gantry, we do have the laser tube in a cover. We have our cable chain bringing all of our electronics up to our head, and then our head that rides on steel rails and steel wheels. This is one of the differences between the Polar Plus and the Polar Lite. The Polar Plus has more linear rods and such for its transmission and movement, but we have the steel rods here. The head does have this shroud on it, so this does come up and off. So this is one thing, check when you're first firing up your laser that this is all the way seated down, but if you do need to do some maintenance, you can slide this up. Let's see, there's the cutout for the beam. And then we do have a stepper motor in here because this does have an addressable Z and autofocus. And so this will be able to go touch off the base, and then it will back off a set amount once it sees that touch off point. You do have your final mirror here, and then you have the laser tube and lens in here. So if you ever do need to take your lens out, there's 2 parts here. There's a top nut and a bottom nut. The top nut holds the laser lens into the tube, and then the bottom one will release kind of the lens tube itself where you can slide this out and swap that out. So that is a maintenance item that you need to keep clean, and every so often you'll need to clean that, or you may have the lens get too dirty, it can get spotted, you need to replace it. It is an 18mm lens in diameter, and then it does have, from what I measured, a 2-inch focal length. So those are readily available on Omtech's site as well as other laser manufacturers as well. Now, if you ever do need to access the laser tube, there are 4 screws, one front and back on the right and the left. You would need to take those out, and then this cover will pop off, and we can get that out of the way. And then you'll see your laser tube does ride on the back of the gantry. This does help simplify the laser path, as that first mirror never moves in relation to your second mirror. But if you ever need to service this or replace it, this is how you will get at it. It does have a couple of straps holding it down. Now, one thing to note, there is a high voltage connection here between the power supply and the tube. This is normal, and this isn't unique to this laser. On occasion, the insulation, there might be an imperfection in it, and you might hear like a static or hear a sparking. I did in fact have that issue with this. So a simple fix was to add a silicone tube over the top of this insulator. So this is a 1/2-inch inner diameter tube. And then I basically just took some silicone caulk and squirted it in the back to just kind of fill that up. Ideally, you'd want to mount this as far away from any metal as possible, but this did provide the insulation just to perfect that connection. So one thing to look out for these, or any CO2 laser, if you're hearing an arcing, be very careful, but inspect to see if it might be that connector there. You'll want to power down your laser, unplug it, let it sit for a bit, make sure that power supply has had a chance to drain off any residual connection, and then you can slide some additional insulation over this. Let's jump into the test that I was able to do with the Omtech Polar Lite. Now, this laser will work with RDWorks if you want some free software. My first laser 10 years ago, I actually started out using that, and it works fine. However, it is also LightBurn compatible. You will need the Pro version. It does have a DSP controller in it, and so you'll need to get the full version of LightBurn. So if you're coming from a diode and you've had kind of their GRBL or their core version, you will need to pay for that upgrade. I would strongly recommend getting this laser with that software at time of purchase, especially if you haven't used LightBurn before. All of my tests were done in LightBurn, and a lot of the tutorials I do are based on LightBurn. It's great software that works with a lot of lasers out there. So let's look at the material tests and projects I was able to complete with this. All right, so starting out, the material I pretty much use as my baseline is 3mm Baltic birch. And so I did set up the material test within LightBurn. As you can see here, we were running from 23mm a second on up to 33mm a second to give us a nice range there. And it was cutting through on up, kind of squeaking out around 30. I did run 2 different tests, so we were kind of squeezing out there at 31 or 32, but I do like to back off the full power and fastest speed for 2 reasons. I try to find the balance between where we're hitting that efficiency curve and where we're just kind of squeaking out a little bit more. What I've found from this is that I can run pretty consistently at 75 to 85% power and still get through around 25 to 27mm a second. Every so often with any material, especially natural material or plywood, you're gonna run into glue pockets and other imperfections. So I always back off that top speed a little bit. Of course, we also ran some scan settings, and I always run these more than once just to make sure I'm getting consistent results. And so this laser tops out at 500mm a second. So I ran these from 200 to 500. That's just based off of some of my experience. I knew that at 100mm a second, we were probably going to get a lot of extra burning. And as you can see at the bottom there, we were getting a lot of vaporization and burning down even at 200mm a second and up in the upper power ranges. So these are good reference points just to kind of get an idea of depth and color on this specific material. So with those numbers, I was able to run cut and engrave project, and I've done this picture before. This is a Star Wars Stormtrooper selfie. It's kind of some fan art that's out there. And I ran this, the Engrave, I ran at 375 millimeters a second, and I ran it from 1 to 50% power. I didn't want to go too deep and get into that second layer of plywood, and so that's where I set it at. I have it at a 0.1 line interval, and that is kind of the default for this one. If you really want to dial this in, you can also run a line interval test to see where you start hitting those spaces, but I was okay with maybe having a little bit of overlap as well. The one thing you'll notice with the CO2 lasers over the diodes is the diodes have more of a sintering burn. It's not as efficient, and so you get kind of less dark effect with the CO2 when it's correctly focused and such. Some of the things you can do and play around with is defocusing it a little bit so that focus point isn't quite so effective as a burn if you want to get some darker colors on wood, but that's something you're going to have to play around with each material. But this actually worked out pretty well. I feel the detail was pretty decent. Of course, you're going to fight a little bit of the wood grain in there, but pretty happy with how that came out. Of course, we can work with thicker materials. So I ran some, this is some 1/4 inch sanded plywood that I think I picked up at Home Depot. I have a variety of different plywood stashes here from various tests, but it's a lighter weight core. I think it was more of like a poplar core versus an MDF core. So I ran this test from 18 to 25, and you can see just at the top, we're just barely squeaking out at 25 with 100% power. So something like this, I would probably back down to about 20 to 21 and then running it there at that 80 to 85% power. Went and took some Baltic birch in 1/4 inch, ran it from the same 18 to 25, and you can see nothing broke through. Even my border didn't get all the way through. So just because you cut through at one thickness of material doesn't mean it's going to do all of that. These have different densities, different glue patterns and such. So you're going to have to test each individual material, but these numbers will give you kind of a baseline of where to start. Obviously with this one, I'd need to back it off a bit slower, probably go from 10 to 15 and find something in that range. Starting out with some 1/4 inch aspen, I kind of just eyeballed or spitballed the ranges there. And so I put the speeds on there at 100% power, started at 14, 15, 13, 12, 10, and we actually got through at 11. And that cut through in a single pass. The edge was pretty clean and caramelized. So I was pretty happy with that. So I ran an actual test, welded some text together that actually says test, and it did cut that through cleanly. There is, of course, a little bit of vaporization overburn that you'd have to clean up on this, but 1/4 inch aspen working pretty well at single pass and 11 millimeters a second. So of course, we wanted to step it up again, had some 1/2 inch poplar this time, and ran a few tests, ended up all the way down at 6 millimeters a second. We were able to cut through. Again, it was a pretty clean cut. Welded some text together, made a little sign there, cut through it. Now you do see again some smoke and vaporization on there that needs to be cleaned up. The edge is pretty dark, but it is mostly caramelized. It's not like really sooty or anything, but just very dark on this poplar. And did cut through cleanly, did have to kind of push through just to get everything to sneak out, but we were able to cut through 1/2 inch material. It may be possible to run through some thicker material, but I think I don't really want to go any slower than 6 millimeters a second, especially not being able to adjust the air assist on this. To maybe compensate for slower speeds. You're probably going to be running the risk of flare-ups, and you really don't want to have those. That can damage your head, that can damage your air assist tubing and such. So I didn't want to go any slower than that, and I didn't want to try any necessarily more dense material. I still think with some extra passes, you could probably get through, say, 1/4 inch oak, maybe some 1/2 inch maple and things like that. But you're going to have to run some tests, and you're probably going to have to add in passes to those to get through them. You're going to be running too slow in a single pass to get through those in what I would consider safe speeds. Now, another test I like to run is a kerf test. My average was 0.188 millimeters for my beam width. So that is also going to possibly affect your line interval, and that's where you might want to do a line interval test, say go from 0.1 to 0.2 and see where you start seeing gaps for engravings. But for cutting and getting your tight fitting, you're going to want to go with an overall beam width of 0.18. So your kerf offset, I would start somewhere around 0.095 millimeters and adjust from there. Every material is going to be slightly different. This is 3 millimeter Baltic birch. Lighter material might burn a little bit more. Thicker material might have a little more of a concave or an angled cut to it just because of the type of the beam, but that is a good starting point for the kerf and your overall beam width of this laser. So of course we can do more than just wood with this. We can work with other natural materials and such, but some of the popular ones that are in my shop, and one of the big reasons you might want to get a CO2 laser over, say, a diode, or maybe add a CO2 if you have an existing diode, is going to be the ability to work with acrylic. And so I ran some tests on acrylic, and the nice thing is this can work with clear acrylic. So using that same cut test, I ran this. We ran it from 18 to 23 millimeters a second. And some 70 to 100% power. With this, we were squeaking out at 90 and 100% power up there at 21 millimeters a second. So again, I'm probably going to back this off. If I'm going to be running this regularly, I'm going to be at around 18 to 19 millimeters a second and around 85% power. But that was getting a nice cut through the acrylic. And I don't know, I'll try to maybe overlay a photo of this, or if I can get it here. It is leaving a pretty polished edge. So a mixture of the air assist and that beam working pretty well to give a nice clean cut in acrylic. No tricks or binders or any weird sprays to make this work. It just works naturally with this clear material. Of course, we can also use colored, so I ran that test again with some yellow. This one getting through at 20, almost at 21. This might be just a little bit thicker or just slightly different, so things are going to vary. Also, again, on some fluorescent yellow here. This one even squeaking out up around 23, 22, 23. All in 1/8 inch material, like I say, 18 to 20 millimeters a second, around 85% power. Now I stepped it up to some 1/4 inch clear acrylic and ran from 12 to 18 millimeters a second, and unfortunately it didn't get through. You can kind of see the depths where it was just wanting to squeak through close at 100. I'm feeling it on the back. But the outside cut was done at 10 millimeters a second. And there again, you get that nice polished edge there looking really nice. So 10 millimeters a second, 1/4 inch clear acrylic, you can cut through with this. Another material that's fun and easier to work with on a CO2 laser is glass and or mirrors. And so I ran a test on the back of a mirror to kind of get the settings for getting through the backer as well as getting a frosted look. And so I ran this from 250 millimeters a second on up to 500 and from 15 to 50% power. Now this laser starts to fire somewhere around 12 to 15% in my tests. So testing all the way down to 10, I don't think it's going to fire at that low percentage, but with glass, lower power, higher speed is going to be your friend. So again, we're not adding any binder to this. Now this had a white backer on it. Some mirrors have more of a gray, but this is kind of a little bit of trying to find the balance of frosting and not chipping or ablating that too much. So for the glass in these mirrors, I'm finding about 30% power and 350 to maybe 400 millimeters a minute will give you a nice frosting effect. And so you can kind of see that effect on the back here. It is still somewhat translucent, but that is frosting the glass and etching through that metallic background. So the settings for glass and mirrors are going to be close. I went ahead and ran the same settings. This is 350 millimeters a second, 30 and 35% power. I ran one at focusing on the glass. The other one, I actually defocused it about 3 millimeters and had a similar effect. This one is a little more aggressive, so I might want to defocus it a little bit more or back that power off even more. You're trying to find the balance between getting that frosting, but not getting it to where it feels too rough and starts chipping away. But again, this is done without any sort of paint or binder. It's right on the glass. Ideally, you're going to do it on the back side. So anytime you're doing this, remember to reverse that image so it comes through and looks clean on the top. So a question I often see is, can a CO2 laser cut through metal? Well, if you get up into high enough power, yes, but at this 55 watt, no. You can remove coatings. You will have some effect on stainless steel, or you can use marking spray, but what it does well is remove the coating from anodized cards or tumblers and such. So this is a business card, ran it at 300 millimeters a second and 30% power, and then just did a quick cleanup with some Windex and or LA Awesome and just a paper towel to kind of get that shine, and worked pretty well. Now I've done these with a lot of different lasers, and this one at those speeds took about 2 minutes, 40 seconds. So it's kind of in there with your diode speeds, a little bit slower than maybe your galvos and your IRs. Now, I mentioned earlier, this is just the base unit, but they do have an option where you can add in a roller rotary. Now, there is a base plate underneath the honeycomb that will pop out. You got to remove 6 screws and you can take out that bottom panel, and that will then open up an area where you can drop in that rotary. With that, you're going to get, I think, 3 inches of space to work with, which is a little limiting. So that's why earlier I showed you, I actually have this up on some 2x4 blocks to get a little bit extra height. And with that, I was able to kind of put this tumbler in stationary, and I was able to engrave my logo on here. Now this is about 1.5 inches wide by 1.5 inches tall, so it's not huge, but it does show the effect. That you can do a small surface of your curved area and still have it work out. This is going to work much better than diodes on all colors of tumblers, because you're basically just finding the setting to get through the material. It doesn't matter what the color is, because this wavelength doesn't really care about the color. So you can do some of these, but they do have a rotary that will work with it. And if you block it up a little bit, you'll get yourself just a little more distance to be able to work on various materials and such. So it is possible and works very effectively. I just cleaned it up with just a little bit of LA Awesome and just a paper towel or a rag to get any of the burning off. If you're trying to do tumblers and coated things, don't try to have it come off the laser just looking perfect. You're probably going to overburn, and maybe if it's stainless steel, you're going to start getting that kind of color change because you're annealing the stainless steel. It'll look a little dirty. You just got to clean them off, and then they'll shine right up. So the other thing that I do a lot of in my shop are various coasters and, of course, slate tiles. So I started out with a grid on the bottom of this round slate tile. This is untreated. This is raw slate. And we ran this from 300 to 400 millimeters a second, and I ran it from 5 to 35, and this is where I kind of found that at the 5 and the 10, it's just not firing. So it started showing up at 15 to 35. There's not a whole lot of difference. You see over there at that 15, it's a little bit lighter. But throughout most of it, it's pretty consistent. So I actually landed on 25% power, 350 millimeters a second, which seemed to be kind of the cleanest and the nicest contrast. And so I ran that and was able to give a really nice engraving. This is kind of a tree of life on here. This is similar to like the IR setting on some of the 2-watt galvos that I have. And it's not as brown or green that you get with some of the diodes. So it's a more brilliant color that I'm seeing here without, having to clear coat it and without using the IR. All right, so overall, it does have kind of the base features that I would look for in a laser. It has a pretty average working area. It is 12 inches deep, 20 inches wide. In some cases, it's always nice to have a little bit of working area. Maybe that could be stretched out to 24, and sometimes you want to have maybe just a little more depth than what your actual piece is. But overall, that's a pretty decent working area, but it does have some limitations. As far as working with a rotary, there is kind of a limit to the height, although if you put it up on some risers like I have, you're maybe going to gain some. I don't have the official rotary from Omtech to look at. I may look at acquiring that or seeing if I can retrofit one of my others using that 4-pin aviation plug and see what we can play with. The exhaust system seems to work pretty well. Having the fans across the whole width of that panel on back does seem to pull the smoke out fairly consistently. I did have some buildup of debris along those fans, and it's easy to clean the outside, but I'm gonna have to look into how well that holds up over time and how easily it is to clean those fans in there. The included air assist pump does seem to do a pretty good job. I did end up having a few flare-ups on some materials, especially when I got into some of the slower speeds. And so that is an area where I do appreciate having more of an external air pump that I can maybe add some variable power to. This one does seem to work okay. I was pretty happy with the cut quality and the speed and the depths of all the various materials, but I do still feel a little limited by that. So I don't know how easy it is going to be to possibly retrofit an air pump into this, or maybe add a relay for external shop air. So that might be a limiting factor. That being said, it does perform very well. You can turn it on and off in LightBurn. It's not just on all the time. So I'm giving it works pretty well, but I would like to have the variability and the ability to kind of just adjust that to my needs and various materials. But with all that being said, at the price point right now, time of video, it is $17.99 for the base model. It works with LightBurn. You will have to add that in. They do offer a bundle package with it, and you will need the pro version of it. For basically $2,000, you have everything you need. You don't need to add an external chiller, and you don't need to add a separate air pump. It just comes out of the box, get it set up, and it works. So if you have kind of a compact working area, you don't want all those extra accessories, that is something that should be able to work well, get you started with CO2 lasers, and be able to jump into more in the future. So I hope this gave you a good kind of general overview of this laser, what comes with it, and what you can do with it. If you have additional questions, hit me up down below in the comments section. And otherwise, also hop on Sunday evenings at 7 p.m. Central. I hop on and do a live stream with my friend David from the Clack Shack. We talk about new machines like this. We answer questions from people with their equipment as well. And that's a good way to follow up with some more questions about this laser or anything else you've seen in my workshop. Again, if you are interested in this laser, I will have links down below where you can find out more of the details on it. And if you use my code VINTARI at checkout, it should get you an extra 5% off your purchase of this or any other laser and equipment at Omtech. So I always appreciate you using those links, but as always, no pressure. I'm just hopefully giving you a good overview of the machine, what it can do, what to expect out of it, and help you make more informed decisions on purchases for your workshop and your hobby or small business. So this is where I'll wrap it up. And thank you again for watching this video. Hopefully I answered all your questions. Again, if not, hit me up in that comment section below and I'll try to get back to you with any questions and possibly do another video on some more detailed questions from you. Otherwise, stay tuned. I do more project videos, I do more product reviews, as well as tutorials, and hope to see you in a future video. But I hope you get it in your workshop and can make something too. We'll catch you soon.